Hi everyone, you're welcome to Best Science Brain YouTube channel. Today we're going to be taking a look at the solution to May-June 2023 Physics WAEC examination. If you are not yet subscribed to this channel, please subscribe to the channel. The address given to you above on the screen, youtube.com/bestsciencebrain. For your lectures in chemistry and physics, both undergraduate and secondary school level. Our email is bestsciencebrain@gmail.com. You can get us on Facebook page on Best Science. You search for us on Facebook, you see our tutorial page, Best Science Brain. Should you have any question to ask, you can forward your questions or can inbox us at Best Science Brain Facebook page to get to us. Now we'll go to the question. We'll start May-June 2023 Physics. The first question there says, the instrument used to measure relative humidity is option A, barometer, option B, hydrometer, option C, hygrometer, option D, manometer. The answer to the question is option C. The hygrometer measures relative humidity. The barometer measures atmospheric pressure. The hygrometer measures relative density. The manometer measures gas pressure. So the answer is C, hygrometer. Number 2, which part of the human eye performs the same function as the diaphragm in a lens camera? The diaphragm restricts the amount of light entering the camera, so excess light from entering the camera. Option A, choroid, option B, iris, option C, cornea, option D, retina. The answer number 2 is the iris. Option B is the right answer. Number 3 question. Question number 3. An electron moves from an energy of minus 8.6 electron volt to another level of minus 3.5 electron volt. Determine the frequency of the absorbed radiation. 1 electron volt equivalent to 1.6 × -19 joules. The Planck constant is 6.6 × -34 joules second. Option A, 1.24 × 15 Hz. Option B, 2.93 × 15 Hz. Option C, 3.59 × 16 Hz. Option D, 5.39 × 16 Hz. The answer to this question is option A, 1.24 × 15 Hz. How do we prove our answer? We'll go to the solution aspect. We see the higher energy level is minus 3.5 electron volt, denoted with E2. The lower energy level is minus 1.86, denoted with E1. The electron absorbs radiation that is pointing up, moving from lower level to higher level. The energy of the photon emitted is taken at the difference between E2 and E1. As you can see, the energy of photon is E2 minus E1, that which is minus 3.5 minus 8.6. Solving that, we arrive at 5.1 electron volt. We now convert that energy to joules. Since 1 electron volt is 1.6 × -19 electron joules, so multiply 5.1 by 1.6 × -19, we get 8.16 × -19. That is the energy in joules. So this is the energy of radiation absorbed. Recall Planck's equation given by energy equal to Planck constant H times F. Making frequency the subject of the formula, F becomes E over H. Then substitute the value of energy and the Planck constant in that equation, we now have 1.24 × 15 Hz. Option A is the right answer. Quod erat demonstrandum. Going over to number 4, a ball of mass 0.8 kg is dropped from a height h just before hitting the ground if velocity is 5.0 meter per second. Determine h, taking g as 10 meter per second squared. A 1.25 meters, B 1.60 meters, C 4.0 meters. To solve this problem, the right answer to this question is option A, 1.25 meters. So let's look at the solution to this problem. Look at the schematic diagram there. You can see the ball of mass 0.8 kg dropped from a height h and falling to the ground level. When the ball is at the top of the height, it possesses maximum potential energy. But as it falls, its potential energy is being changed to kinetic energy as well as potential because it's still at a high from level ground. When it's about to hit the ground, the potential energy is fully converted to kinetic energy, whereby potential energy now becomes equal to the kinetic energy. So from the solution, we say just before hitting the ground level, the maximum potential energy of the body has been converted to maximum kinetic energy. So we can now say PE mass equal to KE mass. PE potential energy is mgh, kinetic energy is half mv squared. Eliminating m on both sides, m cancels m, we now have gh equal to half v squared. Cross multiplying 2 going back to that side, we now have 2gh equal to v squared. Making here the subject, dividing both sides by 2g, we have this formula v squared equal to 2g. Then substituting the velocity is 5 meters per second squared, the acceleration of gravity is 10. We have 5 squared 25 over 20 giving us 1.25 meters. The answer is option A. So going to question number 5, which says which of the following statements about latent heat are correct? I, when ice melts, latent heat is absorbed. I, when water freezes, latent heat is given off. I, when water evaporates, latent heat is absorbed. IV, when water vapor condenses, latent heat is absorbed. The right answer is C, I, and I only. Number C says, increase the frequency of sound wave produces a sound width. Increase the frequency of sound wave produces a sound width. A, longer wavelength. B, reduced loudness. C, higher pitch. D, more overtones. The answer to number 6 is C, because the pitch of sound wave depends on frequency. The higher the frequency, the higher the pitch. Number 7 says, with the following diagrams illustrate the mode of oscillation of air in a tube for the first overtone. We have some diagrams there. First, the diagram represents an open tube because the both ends are open. So, and the first overtone of an open tube is nothing but the second harmonics. So, number 7, the answer is B. Going to number 8. In a mass spectrometer, an ion of charge Q and mass M moving in a path of radius r in a field of flow density B has a speed of option A, mr over qb, option B, mq over qr, option C, bqr over m, option D, mq over br. The answer to this question is C. How to prove is that is C. Let's go to the solution. The radius r of an orbit in which an ion of charge Q and mass m is moving with a velocity v determined by the relationship mv squared over r equal to qvb, where b is the magnetic flux density, qvb, which is this, qvb is force, the magnetic force acting on the ion or charged particle. mv squared over r is the centripetal force on the ion. Dividing both sides of equation 1. Equation 1 is the equation above. Dividing both sides with m. with mass, we get the relationship we have here in equation 2. V squared over R equal to QVB over M. Then the next, we divide both sides with V, velocity. Divide both sides with V. We now have the relationship under, which is equation 3, V over R equal to QB over M. We now make V the subject of the formula by cross multiplying, and making V the subject of the formula, we now have V equal to QBR over M. Option C is the right option. What erat demonstrandum. So number 9 says a sound of frequency 512 Hz reaches the listener 100 meters away. If the sound travels in air at STP, what is its wavelength? In bracket, how speed of sound in air as 331 meter per second. Option A 0.195 meter, B 0.646 meter, C 1.550 meter, and D 5.120 meter. The answer to this question is option B. The solution is given below. The speed of sound or velocity of sound is 331 meter as given in the equation. The frequency is given as 512 Hz. Wavelength is what we're looking for. Wavelength is given by velocity over frequency. Substitute the values of velocity and frequency into this formula. We'll now have 331 all over 512, and that will give us 0.646 meters. That is option B, the right answer to the question. Number 10, in Rutherford's scattering experiment, a beam of alpha particle was fired at a thin gold film, and few of the particles were deflected considerably. This showed that the nucleus of an atom A contains protons and electrons distributed in a tiny volume. B is positive charge and is concentrated in a tiny volume. C is distributed in a tiny volume and emits alpha particles. And then D is concentrated in a tiny volume and contains alpha particles. The answer to number 10 is B, is positive charge and is concentrated in a tiny volume. Those positive particles are the protons. This experiment led to discover proton by Ernest Rutherford. Number 11, a charge of 10 coulombs is transferred across a potential difference of 220 volts. Determine the work done. Option A is 22 joules. Option B 210 joules. Option C 230 joules. Option D 2200 joules. The answer is D, 2200 joules. Let's look at the solution. The work done in an electric field is given by the formula W equal to Q times V, while Q is the charge, 10 coulombs given the equation, and V the potential difference of voltage, 220 also given the equation. So substituting in the equation W equal to QV, that is 10 times 220 giving us 2200 joules. Option D is the answer to number 11. Going to number 12, a solenoid is constructed by winding an insulated copper on a long test tube. A constant direct current is passed through the solenoid. The following actions will not increase the strength of the magnetic field of the solenoid: inserting A, nickel in the test tube, B, brass rod in the test tube, C, soft iron rod in the test tube, and D, steel rod in the test tube. The correct answer to this question is option B, because brass is a non-magnetic material, so it cannot have any effect on increasing the magnetic field of that solenoid. That is Michael Faraday's law on experiment on electromagnetic induction. Going to number 13, the following statements are advantage of solid dielectric material between the plates of a capacitor, except that A, it keeps the plate in the field separation. B, the amount potential difference the capacitor can withstand is increased. C, the capacitance of the capacitor of given dimension is much greater than that of the plates in a vacuum. And then D, it increases the electrical conduction of the capacitor. The electric material tends to decrease the flow of current through the parallel plates. The answer to the question number 13 is D. So that is wrong. The answer is D. So 14 says the following statements about a ferromagnetic material is correct. It A. Attracts non-magnetic materials. B. Has low relative permeability. C. Repels other magnetic materials. And D. Has a high susceptibility. The answer is D. Number 15. A ball P is released from the roof of a building at the same time as another ball Q is thrown vertically upward from the base of the building. The following statement is correct. A. The acceleration of P is greater than that of Q and both are in the same direction. B. The acceleration of P is equal to that of Q and both are in the same direction. C. The acceleration of P is equal to that of Q and both are in opposite direction. D. The acceleration of P is less than that of Q and both are in the same direction. The answer is C. The acceleration of P is equal to that of Q and both are in opposite direction. Number 16. A particle of mass m and radius r. A particle has a mass m and radius r. If the universal gravitational constant is g, what is the expression for the escape velocity of an object on the planet? A. 2g over r, square root of 2g over r. B. Square root of gr of gr over 2. Then option C. Square root of gm over r. Option D. Square root of 2gm over r. The answer to number 16 is D. Number 17. The specific latent heat of evaporation of lead is 8.7 times power 5 joule per kilogram per Kelvin. This means that 8.7 times 10 power 5 joule of thermal energy required to change A. Option A, 1 kg of molten lead to vapor at constant temperature and pressure. B, 1 kg of lead solid lead to vapor at constant temperature and pressure. C, a given mass of molten lead to vapor at constant temperature and pressure. D, 1 kg of molten lead to vapor at every degree rise in temperature. The answer to the question is A, 1 kg of molten lead to vapor at constant temperature and pressure. Number 18 says a 100 kg device is pulled up an inclined plane at 30 degrees horizontal with a force of 1000 Newton. If the coefficient of friction between the device and the surface is 0.25, determine the total force opposing the motion, taking G as 10 meters per second squared. Option A, 216.5 Newton. Option B, 283.5 Newton. Option C, 716.5 Newton. Option D, 975.0 Newton. The answer to that question is option C, 716.5 Newton. How do we explain this? Look at the diagram showing the inclined plane. The 1000 Newton force putting it up the plane. The normal reaction acting up. The weight, which is mg, acting downwards. They have two forces, F and Fs, acting in the opposite direction to the force pulling it. So the F represents the frictional force, while Fs represents the sliding force. The angle of the inclined plane to the horizontal is 30 degrees. The forces that will oppose the motion is the sliding force plus the frictional force. The sum of these two forces be the force that oppose the motion of the object of the plane or the device or the plane. And they will know that weight is mg, mass times, so the weight down there should be 1000 Newton also, mass times acceleration due to gravity. Then coefficient of frictional force is frictional force over normal reaction, making F the subject. F will now become coefficient times R. Then that is here. And then our R is nothing but the weight times cos of the angle to the horizontal, what I call it angle theta or angle phi. And then our weight is mg. So we now have mg cos theta or cos phi. That is the normal reaction. So substituting in this formula U R, replacing R with mg cos theta, we now have U mg cos theta. So this formula is for obtaining the frictional force acting on the load, on the device, on the plane. Okay, having done that, we'll now go to the other side. The sliding force that will slide it down the plane again by W sine theta, and W is the weight, which is also mg sine theta. Total opposing force is the sliding force plus frictional force. We now bring the formula for sliding force and that of the frictional force, substitute the values accurately, and we're going to get 716.5 Newton. Option C, pure ED. Number 19, two objects A and B accelerate from rest at uniform rate. B accelerates twice as much as A. Compared to A, B travels, option A, 2 times as far, B 3 times as far, option C 6 times as far, and option D at the same distance as A. The answer to this question is A. B travels 2 times as far. You can prove it using the uniform accelerated equation of S equal to ut plus at squared. You prove it, you know that B, substitute the actual values, taking your u as 0. So you find out that B travels twice as fast as A. Number 20, you have a diagram there. You say the diagram above illustrates a hot metal suspended at the center of a closed uniform bus. Thermometers E, F, and G. E, F, and G, E, F, G, and H are placed in contact with the 4 sides of the bus. Which of the thermometers will register the highest temperature? Option A, E, option B, F, option C, G, and option D, H. Looking at the diagram, the thermometer that registers the highest temperature is the one up there, E, because the rays will be moving vertically upwards. So the answer to the question is option is E, which is option A. A is the right answer to number 20. Number 21. A liquid left in an open ditch after several days. There is less liquid in the ditch. The following statement explains this observation. Option A. Most energetic molecules leave the surface and return. B. Most energetic molecules leave the surface and escape into the air. Option C. Least energetic molecules leave the surface and return. D. Least energetic molecule leave the surface and escaped into the air. The answer is B. Most energetic molecules leave the surface and escape into the air. Going to number 22, said the colors of visible light region of the electromagnetic spectrum had the shortest and longest wavelengths, respectively at A. Red and blue, B. Yellow and blue, C. Indigo and violet, and D. Violet and red. Remember the colors of the rainbow roy beef. Red had the longest wavelength and violet had the least wavelength. So the least is violet and the longest wavelength is red. So the answer is option D, violet and red. Number 23, the following equations is not a correct mirror formula. The symbols have their usual meaning. A, 1 over F equal to 1 over U plus 1 over V. B, N equal to 3/6 over theta minus 1. C, F equal to 1 over D. And D, M equal to V over U. The answer to the question is option C. All other formula are for mirror, while option D is for lens. Number 24. An atom in an excited state is one whose A. Potential energy is minimum, B. Potential energy is maximum, C. Electrons are in the conduction band, and D. Electrons have moved to a higher energy level. The answer is D. Electrons have moved to a higher energy level because during excitation, the atoms undergo a quantum jump to a higher energy level, from lower to higher energy level. Number 25. The conclusive test of magnetism in a steel bar suspended horizontally at its midpoint is when the bar A. always settles in the magnetic north-south direction, B. always settles in the magnetic east-west direction, C. is repelled by a magnet, D. is attracted by a magnet. The answer is A. always settles in the magnetic north-south direction. That's the truth for a magnet. 26. The following devices is used to compare relative magnitude of charges on two given bodies. A. the electrophorus, B. ebonite rod, C. proof plane, and D. gold-lead electroscope. The answer is the gold-lead electroscope. Number 27. A direct current cannot pass through a parallel plate capacitor because A. the plates are non-conducting, B. the plates have equal but opposite charges, C. there is leakage of charge from the plates, D. the dielectric between the plates is non-conducting. The answer is D. The dielectric between the plates is non-conducting. 28. The process of producing electric current by a changing magnetic field is referred to as A. flux leakage, B, magnetic induction, C, electromagnetic induction, D, electrostatic induction. The answer is electromagnetic induction. Number 29. The sagging of overhead electric wires is caused by A, rough handling, B, radiation of heat, C, linear expansivity, and D, gravitational attraction. The answer is linear expansion, option C to number 29. Number 30. A cell of EMF 2 volts has an internal resistance of 0.5 ohm. If a current of 0.4 ampere passes through an external resistance P, internal resistance of P. Option A, 5 ohms. Option B, 4.5 ohms. Option C, 4.0 ohms. Option D, 1.0 ohms. The right answer to the equation is option B, 4.5 ohms. So how do we get the answer? We have a diagram there representing, have the cell, 2 volts, the internal resistance under it 0.5 ohms, the current flowing 0.4 ohms, the load or resistance P, then everything listed outlined for you down, E, 2 volts, and so on. I 0.4, the internal resistance small r, internal resistance 0.5, then the external resistance is P. R now becomes equal to P. Using the formula for finding the current in a circuit, I equal to E all over R, big R plus small r, and substituting I is current 0.4, our EMF is 2, all over this big R now is equivalent to P, then plus R, small r is external resistance, and that R should be 0.5, small r is 0.5. Then we can apply, okay, it is there, we can apply 0.5, then we can apply, we now have 0.4 times P times 0.5 with the value of R, small r, equal to 2. Solving out and looking for P, we now have 1.8 over 0.4, P gives us 4.5 ohms. So option D is the right answer to that number. Number 31. The property of a body that determines the direction of heat flow when the body is in contact with another body is the option A, power, B, heat capacity, C, temperature, and D, mass. The answer to the question is temperature, option C to number 31. So we'll go to number 32. It says in an RLC series circuit at resonance, the voltages across resistor and inductor are 30 volts and 40 volts respectively. Determine the voltage across the capacitor. Option A, 30 volts, B, 40 volts, C, 50 volts, and D, 70 volts. The answer is option B, 40 volts. Why? The solution is given below. At resonance in an RLC circuit, inductive reactance is equivalent to capacitive reactance. That means SL equal to SC. SL is inductive reactance and SC is the capacitive reactance. Since the capacitor and inductor are in series, the same amount of current will flow through them. That means current flowing through the inductor is equal to the current flowing through the capacitor, which is taken as I. And the voltage across the capacitor or inductor given by current times the reactance. So since the current is the same and then the reactance are the same, that means the voltage between them will be the same. The answer is 40 volts. Option B is the answer. Number 33. The purpose of a commutator is in a direct current motor is to A, increase the efficiency of the motor, B, reverse direction of the current after every half motion, C, enable a motion, a uniform couple to act on the coil, D, increase the number of rotation per second. The answer is B. The commutator reverses the direction of the current after every half motion. Number 34. A lead bullet of mass 0.05 kg is fired with a speed of 200 meters per second into a lead block of mass 0.95 kg at rest. Given that the lead block moves after the impact, determine its kinetic energy. Option A, 50 joules. Option B, 100 joules. Option C, 150 joules. Option D, 200 joules. The answer to the question is 50 joules. Option A is the answer. The solution is given down. During collision, we can see the representation there. The arrow with green color represents the bullet flying of mass 0.05, and then initial velocity of 200 meters per second, flying onto the lead block of mass m2 0.95 kg. Initial velocity is 0 because at rest, and collision is perfectly inelastic. Why do you say that? Because the bullet will stick or will be stuck into the lead block, and both objects will move with same speed. So when the bullet is firing into the lead block, it's going to find itself stuck into the lead block, and the collision whereby two objects join themselves after collision is called inelastic collision. So look at it, the diagram after collision, the two of them are together. So, and then we'll have the value, and if they're together, they will have the same common velocity. V1 becomes equal to V2 or V. Applying the principle of conservation of linear momentum, total momentum before collision equal to total momentum after collision. M1U1 plus M2U2 equal to M1V1 plus M2V2. And mind you that V1 and V2 are equal because after collision they have the same common velocity. So we now factorize that side. M1 V1 plus M2 V2 now become, replacing V1 and V2 with V, we now have this expression. Then substituting the values there and solving out for V, we have the common velocity of the bodies as 10 meters per second. Then the composite bodies, both the bullet and the lead, will have the same kinetic energy after collision. Then we have to calculate the KE after collision using this formula below, and we got 50 joules of energy. Option A is the right answer. So look at question 39. The 39 says the diagram below illustrates a mode of vibration of a wire of length 125 cm. The speed of the waves along the wire is 120 meters per second. Use the diagram to answer question 39 to 40. As you can see the diagram there. Okay, and we ask number 39, determine the wavelength of the waves. Option A 0.25 meters. Option B 0.50 meters. Option C 0.75 meters. Option D 1.00 meters. The answer to number 39 is option B. So how do we prove that? We know that we count the number of lobes. 1, 2, 3, 4, 5. I will know that at each end, this is a stationary wave. At each end, what I would call node, and that node, and that node, and that node, and that node. And the distance between any two consecutive nodes is wavelength over 2. So let's go to the solution. The distance between adjacent nodes S is half wavelength, and there are 5 consecutive loops. That's as we counted before. There are 5 of them. Then what then do? We now say, since there are 5, now say 5 lambda. There are 5 wavelengths over 2, because the distance between one node and the other is lambda over 2. 5 lambda over 2 equal to the full length of the string, which is 125 cm. We make lambda the subject. Lambda now becomes 2 times 125 over 5. That will give us 50 cm. In SI unit is over 100. That will give you 0.5 meters. Option B is the right answer. Number 40, with respect to the same question, the same diagram, they say determine the frequency of the wave. A 24 Hz, B 192 Hz, C 240 Hz, and D 286 Hz. The answer to that number 40 is C, 240 Hz. How is 240? Frequency, velocity over wavelength. Already velocity of the wave given to us in the equation in bracket as 120 meters per second, and then the wavelength which we obtained from question 39 is 0.5. So divide 120 by 0.5, you have 240 Hz. Option C is the answer to that question. Number 41 says, which of the following statement about the properties of electric field produced by the charged parallel plates is not correct? A, the electric field in the region after the parallel plate is 0 except for the edge effect. Option B, the electric field is uniform everywhere in the space between the parallel plates. C, the magnitude of electric field strength at any given point between the plates. The magnitude of electric field strength at any given point between the plates, except near the edges, depends on the magnitude of the charge on each plate. D, the magnitude of the electric field strength at any point between the plates is directly proportional to the magnitude of the charge on each plate. So the answer, which of the statement is incorrect? The answer is C. The magnitude of the electric field at any point between the plates except near the edges depends on the magnitude of the charges on each plate. So the answer to number 41 is C. Number 42 says a car P with a velocity of 30 meters per second is traveling in the same direction as car Q with a velocity of 20 meters per second. The velocity of P related to Q is A 50 meters per second, B 45 meters per second, C 20 meters per second, and D 10 meters per second. So this question is under relative speed. When two objects are moving in the same direction, the relative speed is obtained by subtracting their speeds. That is 30 minus 20. The answer is 10. Option D is the answer to number 42. Number 43. The range of wavelengths of the infrared waves in the electromagnetic spectrum is 10 power minus 6 meter to 10 power minus 6 meter. The wavelength of radiation is, so you are given the range, and look at the range, you see that 10 power minus 6 is lower range to 10 power minus 3. That means the wavelength of the ray must be longer than 10 power minus 6. Look at the option. Option A equal to 10 power minus 3 meter. Option B longer than 10 power minus 3 meter. Option C shorter than 10 power minus 6 meter. And then option D longer than 10 power minus 6 meter. The answer is D, longer than 10 power minus 6 meter. Number 44. When an electron jumps directly from an orbit of n equal to 4 to n equal to 6, A proton is emitted, B, a photon is emitted, C, 2 photons are emitted, D, 2 photons are absorbed. So you jump directly from n4, from a higher state to a lower state. The answer is B, a photon is emitted. Number 45. When a lightweight body and a massive body are acted upon by the same force for the same period of time, they A. Momentum of both bodies remain the same. B. Latter body has a higher momentum. C. Maximum body has a higher momentum. D. Maximum body builds up a higher momentum. The answer is A. Momentum of both bodies remain the same. So why the answer to number 45A? You see that the body, the light body and the weight body are acted upon by the same force for the same time. I will know in physics, impulse is force times time, and impulse is equivalent to changing momentum. So since they're acted by the same force for the same time, they'll have the same impulse, and of course will have the same changing momentum. Number 46. The following devices is associated with alternating current only. Option A, induction coil. Option B, lead acid accumulator. Option C, step-up transformer. Option D, moving coil galvanometer. The answer is C, step-up transformer. Number 47 says a body starts with an initial velocity of 2 meters per second and moves with a uniform acceleration A for 15 seconds. The following equation represents the distance traveled, S. Option A, S equal to 300 plus 225 over 2A. Option B, S equal to 300 plus 2A over 225. Option C, S equal to 300 plus 225A over 2. Option D, S equal to 300 plus 225 over 2. The right answer to that question is option C, S equal to 300 plus 225 over 225A over 2. Look at the solution. The initial velocity of the object is 20 meters per second. Acceleration is taken as A because it's not given. Then the time, okay, they say the acceleration is taken as A in the question, yeah. So as A, yeah. So let's continue. The time of motion is 15 seconds. We now apply the equation for uniform accelerated motion, S equal to ut plus half at squared or at squared over 2. Solving out and putting the values, we now have u is 20, t is 15 plus a, then t 15 squared over 2. When we solve it, we now have 20 times 15 is 300, 15 squared is 225, a over 2. Option C is the right option. Number 48 says the ratio of the maximum range to the maximum height of a projectile is for determining the angle of flight, angle of projection A, 0 degree, B, 30 degree, C, 45 degree, and D, 60 degree. The answer is C, 45 degree. How to prove that? Maximum range operated given by u squared over 2g, where u is the initial velocity, y height given by u squared sine squared theta over 2g. Then the ratio of range to height is arrow mass over height equal to 4. If you solve and then put in the values accurately, look for theta. Theta will give you 45 degrees as your answer. Number 49. With the following statements, our observation. The following observations are the following statements are observation made about a towing vehicle and a bus that is being towed. 1. The force exerted on the bus by the towing vehicle is of the same magnitude as the force that the bus exerts on the road. 2. The force exerted on the bus by the towing vehicle is of the same magnitude as the force exerted on the towing vehicle by the bus. 3. The towing vehicle exerts a force on the bus greater than the force exerted by the bus on the towing vehicle. And C. The towing vehicle exerts a force on the bus that is the same as the force that the road exerts on the towing vehicle. The answer to the question is B. II is the answer. The force exerted on the bus by the towing vehicle is of the same magnitude as the force exerted on the towing vehicle by the bus. This is the Newton's law of third motion. To every action, there's an equal and opposite reaction. Number 50, you have a velocity time graph there. We have to find distance traveled along SY. The SY gives us a rectangle, and then the width of the rectangle is 4. That is 8 minus 4 gives us 4, while the height of that rectangle is 40. So the area of that SY is the length times breadth, that is 40 times 4, giving us 160. Option D is the right answer. So thank you very much for listening and for staying tuned, and always stay connected to Best Science Brain YouTube. Thank you.